0.2, 0.5, the p-value. Wow, more and more terminology, but we slowly build. Never mind, don't worry, we can do this. Actually, I feel like showing the video to this recorded video to the next lecture group. No, I don't want to repeat again. Haha. 7.2.5. Now we talk about this, okay? Now let's recall in our example, x bar, which is your sample mean. That means your population, you take 1, 2, 3, 4, 5, 6, 7, 8, 9. This is your sample mean. Correct? It's your population. Yeah? Recall that I order pizza 9 times, I get 38.2. Correct? And we also recall calculating this probability. If H naught is true, i.e. mu is equal to 30, then x bar follow a normal distribution with mean 30 and 9 square over 9. I copied this so many times that I can memorize. Now therefore, we also say that, oh, okay, this is 30. Remember at the start we said, what if this is 38.2? What was this probability? This probability is probability x bar greater than 38.2, which is 0.003135. You recall? Yes, then we say, oh, okay, therefore it's rare event, therefore this is smaller than the level of significance. Rare event, I say, therefore H naught is not true to begin with. I'm going to say 3 things. First thing, this is what we call the p-value. Terms doesn't mean anything to us. Let's be very clear about what this p-value means. This p-value is the probability of getting 38.2 and getting 38.2 or greater. Correct? In this context. It is actually the probability that x bar takes a value as extreme as the observed value in the test. Now let me break it down a little bit. This is the observed value, 38.2, right? Surely I can calculate probability x bar taking a value as extreme as 38.2. Follow? So this is calculated, this definition of p-value is like that. Why do I specially calculate p-value? It's very simple. Remember when right at the start I said, oh okay, right at the start I said, the smaller this is, the more evidence I have to reject H naught. Correct? The smaller this is rare event, right? That means it's quite unlikely that I will end up here, ma. Correct? Therefore, I say this assumption was not true to begin with. So, I write down. Second point. The smaller the p-value, the more evidence we have against H naught. Makes sense, right? That means the smaller this value is, that means it's very rare, therefore we have more evidence against H naught, then we can say that H naught is true. And we can actually make our decision based on the p-value as well. Remember? I don't know whether you recall. We can use it for decision making now. If p-value is smaller or equals to your alpha, which is your level, I use alpha as level of significance. What conclusion will you make? smaller than 5%, what conclusion will we make? Do you reject H naught or do you accept H naught? Smaller. Think. This is the probability is very small. If probability is small, it would suggest that it will be far away from the mean. Would you reject H naught or accept H naught? Reject, very good. You will reject H naught. If your p-value is greater than alpha, then you do not reject H naught. Now that is the definition of the p-value. That's the breakdown of the p-value. Okay? Can? Okay. Finally, I think we can start copying already. Yeah, I think we can start copying. Okay, let's go on. Let's go back to the notes. Yeah. Okay. 7.3. So now I'm going to detail the steps. If you are given a problem, how would you do a hypothesis test? Okay, can? Step 1. This is page. Can I have an idea which page is this? Sorry? 7. Oh, finally we are at page 7. My goodness, not so much, still at page 7. Okay. Can. Okay, page 7. Can start copying finally. First step, I got to define the random variable and the population mean. So we always, in the pizza delivery problem, okay, now those people come, wake up. Time to copy already. We will let x be the pizza, the delivery time, and mu minutes be the population mean of x. That's what in the example. So first step must define. You don't define how to do. Goodness. Next, you have to state the null hypothesis and alternative hypothesis. In our example here, our k was 30, right? In our example, our k was 30, right? Correct? In the pizza delivery. Right? In the pizza delivery, our k was 30. Now, you decide whether you want to have against your h1. Your h1 could be mu greater than k, or your h1 could be mu smaller than k, or your h1 could be mu not equals to k. There are 3 cases. You can only choose one. You cannot do all in one test. Correct? That's our objective. Which one do you want to do? You choose one depending on the context. Next, you state the level of significance. Your level of significance could be 5%, 10%, etc. Doesn't matter, but you must state whatever percent that you. I put 100 alpha means 100 alpha percent means if, example, alpha could be 0.05. Imply level of significance is 5%. Correct? You do the math, you know why I do this. Alpha is the absolute number. Correct? Alpha is the probability. 100 alpha is 5%. Correct? Step 4. State the test statistic to make it clear which you are using. Okay, this one I'll explain later. But most of the time, it's either Z test, which we have dealt earlier. Remember the standard normal? The T test is not discussed yet. Don't worry about it. Okay? Step 5, you compute. We'll explain later, don't worry. Okay, all this we'll explain later. Remember this decision making? If p-value, that means if it's rare, you reject. If p-value is not so small, you do not reject. And finally, you conclude. Okay, let's move on again. Usually, and I wouldn't even say usually. In hypo testing, in the syllabus, our x will always be a continuous random variable. Okay, will always be a continuous random variable. No, I correct myself. X bar will always be continuous random variable. Okay, but if your x, so there are two cases here. Look, remember in our pizza delivery, if population is normally distributed, that means x is normally distributed, x bar will be normally distributed no matter what is your n. Remember? Remember? So therefore this must be normally distributed. Now remember central limit theorem? Now if your population is not normally distributed, can we still do the test? Yes, we can, as long as your n is large. If n is large, you can use central limit theorem to say that therefore x bar will still follow a normal distribution. Then you can still standardize it to get your standard norm. So very easy. I don't want to say too much. Okay? Can? Okay, let's go to the example. Example 1. Wait. Pause.